Lesson 7.3b is in Bravo. And let's go ahead and look at the first part of this matrix multiplication. Suppose Circuit Town made a special purchase for one of its stores consisting of 22 TVs, 15 washers, 12 dryers, and if the value of each television is $550, each washer is $435, and each dryer is $325, then the value of this purchase is, which makes perfect sense, the entire purchase is the cost times the number of TVs, the cost times the number of washers, and the cost times the number of, what were those, dryers. And when I add all those together, I get $22,525. Okay? So if I want to do this in matrix form, I can say A is the cost per TV, washer, and dryer. So again, I'm trying to talk and write something different at the same time. And I can write B as the cost, or how many of the TVs, the washers, and the dryers. Okay, so notice, one is in row and one is in column format here. Okay, so let's put this up here. And what we can do is we can multiply. And the way we multiply is we say AB equals A. One of the things about matrices is they're not commutative, which means in math or in arithmetic you can say 3 times 5 is the same as 5 times 3. You get the same answer either way. When you do matrices, that is very rarely the case. So if you have it written as AB, you have to list it in the exact same order as AB. Okay, so this is just a real simple 1 by 2 matrix there and a 3 by 1 matrix there. Okay, that's the dimension. 1 row times, 3 columns and 3 columns by 1 row. And one of the things that will happen when you're multiplying matrices, before you multiply, there are a couple things that have to be true. If they're not true, you cannot multiply. And that being that this number, the second number, and the first number of what you're multiplying have to be the same. If they're not the same, you can't do it. And the end result, the matrix after you multiply, will have the dimension of the first number and the last number. So our answer will be a 1 by 1 matrix, meaning it will have 1 row and 1 column. Very important to write that down in your notes. It'll save you a lot of hassle, because if you see somewhere along the line that this second number and this first number are not the same, then you can't do it. And you also know the size of your answer, the first number and the last number. So it's a 1 by 1. So it's kind of nice to put 1 by 1 there so you know that you're going to have a matrix that basically has one number in it, and that's it. So how do you multiply this? Okay, this one is probably, out of all of the multiplication of matrices, they start off with this one, and I think it's actually harder than the other ones, but we'll go ahead and do it. So what we do is we multiply first number there times the first number there. So I'm just going to write this. Then we're going to add the middle number times the middle number. And then we're going to add the last number times the last number. Okay, when we're done, when we figure that all out, we're going to get a 1 by 1 with our answer here. And this is the same number that we got clear up here when we did this. Okay, so one of the things that's really important here is this looks like a ton of work, and it is. And it would have been easier, I'm sure, when you look at this and go, man, it'd be so much easier to do that. Forget this matrix stuff. But when you get into more complicated ones, the matrix idea will be the quicker. Okay, so anyway, they give us a whole bunch of stuff here on page 540, but what I'm going to do is I'm going to go right into doing some matrices, some multiplying matrices here, just to give you a feel for what happens. So we're going to start out with a small one, which is example 5, and they say that A equals and B equals, why do they do that? I don't like example 5 because they're mixing numbers and letters. Let's just forget that. Let's go to the example 6, and we're going to multiply that matrix together. So let me write, I'm going to turn this off and write it out, and then we'll go through it. Okay, so that's what we're going to multiply. So first of all, we're going to write down that this is a 3 by 3 matrix, and this is a 3 by 2 matrix. And I know this will work because my second number and first number are the same, so that means they're multipliable. It also means that my answer will be a 3 by 2 matrix. So I know my answer is going to be a 3 by 2 matrix. All right, and this is what I do, and this seems to help students. So this is the way it made it easier for me. So what I do is I make my answer matrix here, and I know it's a 3 by 2, so I know I have 1, 2, 3 rows and 1, 2 columns. Column 1, column 2. Okay, so what I'm going to do is I'm going to fill in these 6 blanks with numbers. Okay, and those 6 numbers then will be the answer to this matrix. So I like making my answer thing because that tells me exactly how many answers I'm going to get. Okay, and I can fill in these blanks in any order I want. I could start out putting a number in here, but where the heck am I going to get the number to put in there? And that's what we're going to go with. And that's where it's very important to start off doing it this way. In fact, even doing these for 20 years, I still make my little answer matrix right here. But what I'm going to do, I'm going to make it a little bigger. So I'm going to erase my second column here for this first one. And I'm going to make my lines bigger because I'm going to start out kind of showing you a lot of detail so you see where things come from. There. So I still have my 6 blanks here. Okay, so this blank right here is in fact, I'm going to write that over here to the left. It is my first row, first column, and that's all I'm interested in right now. First row, first column. First row, first column. I don't care about any other numbers except those 6 that I circled. All right, so what do we do here? We take the first number in the row times the first number in the column. Add second number in the row, second number in the column. So I multiply those. Add third number in the row, third number in the column, which is 70. Now in the book, I put a 14 there. They have a 15 there, but it doesn't really matter. You do everything the exact same. I'm just going to get a different answer than the book does, but that's okay. I get the right answer for what we're doing there. Okay, so then I look at well, let's just say I look at my second, well, let's do something a little bit different. Let's look for this one right there. Okay, this one here is the second row, second column. So second row, second column. So that's what I'm going to circle up above here. Second row, oops, let me use a green pen. Second row, second column. So now I'm going to multiply my first number in the row times the first number in the column. Second number in the row, second number in the column. And get 120, whoops, pencil please. Plus third number in the row, third number in the column. So see, I can, doesn't matter which one I do. Okay, so let's go to the bottom, the third row. So third row and first column. And that will give me the number for that, because this is the third row and first column. All right, so same thing. First number, first number. Second number, second number. Third number, third number. Okay? So you do the same thing for this row, or this one, and this one. And then you just add these numbers up, and those will be the numbers that go into your matrix here. So if we were to show our matrix in its completeness, well, kind of completeness, because I don't have all of my, I didn't do all of them. Okay, I need to make that bigger so things fit. Sorry, it's kind of lame, isn't it, when you have to watch me erase and move things around, and it's like, oh, will you just please get on with it? Okay, so there's my 6. So if I were to take my 36, my 120, and my 70, I'd get 226. If I were to take my 120, my 110, and my 30, I'd get 260. And if I were to take this here and add those together, I would get 268. And then, whatever I get when I add these, and put those in. And that would be my matrix. So that's how you do these. And it does not matter how big these matrices are. It also does not matter if they're, weird things. Like, for example, let me give you one from the book, number 26. And let's say we wanted to multiply A and B together. Now they're asking you to do both, but let's just do A times B. So I would say A, B equals, and let's see if it can even be done. This is a 3 by 3, and this is a 3 by 3. And since these numbers are the same, it's doable. And my answer is going to be a 3 by 3. So I'm going to give myself 3 rows, 3 columns. Okay? So if I'm going to multiply these, let's say, for example, I am interested in finding, and let's make this a little tricky, the number that goes in that space right there. Well, where is that? It is in the second row. Okay, so row 1, row 2. So it's in the second row, and it's also in the second column. So what I'm going to do is I'm going to circle the second row of the first matrix, and I'm going to circle the second column in the second matrix. And what I'm going to do then is I'm going to multiply -1, the first number in the row times the first number in the column. Second number in the row, second number in the column. Third number in the row, third number in the column. So I'm going to do that down here. So negative 1/2 times 2 is negative 1 plus 0 times 2 is 0 plus 1/2 times 4 is 2. So the number that's going to go here is the number 1. Come on. Give me my number 1, please. Won't write for me. There we go. Okay. So again, this times this gave me negative 1. 0 times this gave me 0. 1/2 times 4 gave me 2. I add those up, and that number goes there. Okay. If I wanted to, and I'm not going to do this whole thing, but if I wanted to find the number that goes here, that's the third row, third column. First number times the first number plus second number times the second number plus third number times the third number, and you add those three together and you get a number that goes there. That's all there is to it. Okay, I'm sorry that so many textbooks go into all this detail and stuff, and it just seems like it makes it so difficult. And hopefully that makes it easier. I mean, at least it does for me. So hopefully it does for you too. So let's go ahead and just look at a couple of examples here. We're not going to do them, but I want you to at least look at them. The advertising, example 6, they give you a couple matrices based on the information in the advertising, and you'll notice that for the most part, when you look at the exercises for this and the story problems, they will give you a table, and you will be able to figure out, the matrix from that information. So shouldn't be any trouble. I mean, if you look at example 6, they pretty much tell you this is the information, and here's your matrix, and go ahead and multiply those. You can also use the example of using your graphing calculator to do that one. They give you a chance to do that for the example 6 and example 7. And example 8, they give you another one with manufacturing of furniture, and they give you your matrices as well, as far as showing you how to do that on paper, as well as being able to do that on an Excel spreadsheet. All right, so the last thing I want to do is look at the identity matrix. And the identity matrix is basically any matrix, and they will tell you what dimension they want. So for example 9a, they say a 2 by 2. Let me get a different color so you can see it better. And the identity matrix is the diagonals, couldn't remember what it was, is 1, and everything else are zeros. So for example, a 3 by 3 would be 1, 1, 1, and then everything else in the rows and columns would be zeros. Looks very, very familiar to when you were solving for systems of equations using the Gauss-Jordan elimination method, where you wanted all these zeros and all these zeros and your diagonals 1. So it's pretty much the same thing. All right, but I do want to go over just real quickly the matrix times your identity. So in fact, I'm going to go over it real quickly since I'm running out of time here. But they want us to take the matrix A, and they want to multiply that by the identity matrix. And so what they say is, this is A. We know that the identity matrix, this is a 2 by 2, so a 2 by 2 identity matrix is going to look like that. And they want you to multiply those two. Well, it's the exact same way that you multiplied any matrix. So you know you're going to end up with a 2 by 2, and you're going to have a number there, 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 and there. So if we're going to solve and find this first number, It's in the first row, first column. So we're going to multiply 3 times 1 and get 3. And then negative 2 times 0 and get 0. Okay, so the number in here is going to be a 3. And you're going to do the same thing for each of these. And that's it for 7.3. We did it in a long 2 videos, but at least they're done.